Good afternoon, children. Welcome back to your online classes. I hope you are all very happy and safe with your parents. And in your previous class, we have discussed the concept of magnetic field and properties of magnetic field lines and magnetic field lines around a bar magnet and magnetic field lines in a solenoid and also Fleming's left-hand rule. I hope you have learned all the concepts. And today in this class, we need to discuss one more important concept, that is electromagnetic induction. So before going to know the concept of electromagnetic induction, so let me study this activity. So this is an activity to study the electromagnetic induction. For this we need one bar magnet and a galvanometer and a copper wire which is sewn in the form of a cylindrical shape. So arrange all the equipments as shown in this diagram, and so that means arrange the copper wire like this in the form of a cylindrical shape, and at the two terminals of the copper wire, that means the two terminals of the copper wire is connected to the ends of the galvanometer. Now take the bar magnet, keep the bar magnet inside the copper coil. As soon as if we keep the bar magnet inside a copper coil, the magnetic field linking with this conductor in the sense, so this is the entire circuit, we may call this as conductor because there is a pass of current will be takes place, hence this is called as a conductor. As soon as if you place a bar magnet inside the coil, there is a change of magnetic field will be takes place and it induces the current in a circuit, hence the galvanometer shows the deflection. See, we know that symbol of galvanometer, it is always upside at the zero. So if the needle deflects either this side or this side, that indicates that the current will be produced in the circuit. So that means galvanometer is a device which is used to check the presence of a current in a circuit. Now if the galvanometer showing the deflection in this circuit, it indicates that an electric current will be induces. So that means as soon as if we keep a bar magnet inside this copper turnings, there is a change of magnetic field will be takes place, hence the change in magnetic field can produce the current. The current the produced here, it is called as induced current. Induced current in the sense, the current which is produced by varying the magnetic field, or the current which is produced in a closed circuit, it is called as induced current. So this is the case when we have keep the magnet inside the coil. In case if we remove the magnet outside from the coil, see in this diagram you are able to see, so here we have keep the magnet inside the coil. In the second situation we are removing the magnet out of the coil, so again there is a change of magnetic field will be takes place inside this coil, hence there will be a production of electric current. So there will be a production of electric current once again in the circuit, hence the galvanometer shows the deflection. So the galvanometer shows the deflection indicates that what the current is produced. So in first case it is towards left side, but in second case this is towards the right side, just it indicates that the direction of current. That means in first case the bar magnet is keeping inside, so the galvanometer shows the deflection towards this side. In second case we are removing the magnet, so that means reverses the direction of current. So in these two activities you observe that whenever a conductor carrying current placed in a magnetic field, so see this is the conductor, whenever you have placed a bar magnet, it changes the magnetic field. The change in magnetic field produces the current. So this is called as electromagnetic induction. and this was given by a great scientist Michael Faraday. So now here see, look at the definition, the motion of a magnet. So motion of a magnet means if we keep inside, so during keeping only it changes the magnetic field. So that means the motion of a magnet with respect to the coil in the sense this is the copper coil, or a change in the magnetic field induces a potential difference. A potential difference in the sense electromotive force in the coil and induced current. So before this I said you that induced current in the sense the current which is produced by varying the magnetic field, or the current which is produced by the closed circuit. So here there is no connection of external devices or connection to the external circuit, hence it is called as induced circuit, closed circuit. The current produced in this closed circuit, it is called as induced current. So this phenomenon, it is called as electromagnetic induction. So this is very very important, so try to keep in mind. So once again I would like to repeat the meaning. The motion of a magnet, motion of a magnet in the sense we are keeping and removing, keeping and removing. See here you need to observe that when the magnet is moving in the sense only, it changes the magnetic field and current will be induced in the circuit, induces in the sense produced. And if you are removing, once again the magnet is moving, hence there is a change in magnetic field will be takes place. This induces the current in the circuit. See, in case if the magnet is kept at rest, if the magnet is kept at rest, that means remove the magnet, keep the magnet anywhere else here at rest. So there is no change of magnetic field. If magnetic field is not changes, there is no production of the current will be takes place. So keep in mind the relative motion between magnet and coil only causes the electromagnetic induction. That means if the magnet is moving, the current will be produces. If the magnet is at rest, there will be no current produced in the circuit, hence the galvanometer shows zero deflection. So very important, this is keep in mind the motion of a magnet with respect to a coil or change in the magnetic field induces a potential difference. It is also called as EMF, electromotive force, in the coil and produces the induced current. This is called as electromagnetic induction. So this is very very important, children, try to keep in mind. So after knowing electromagnetic induction, the next concept it is change in magnetic field produces induced current. So as just now only you have studied that change in magnetic field only produces the electric current. So for you here one activity is there. The activity is like this: take two coils of wires. So coil 1 and coil 2, take two coils. That means the copper wire is wound in the form of a cylinder shape around a paper or cardboard. See now, take two coils of wires wound around a cylindrical paper roll and connect one coil to a battery. So this is the coil 1, connect the terminals. So that means copper wire terminals are connected to the battery and a switch, and battery and the coil to a galvanometer, and the coil 2 is connected to the galvanometer. So keep in mind, take two coils of wires, this is coil 1, coil 2, connect coil 1 to the battery and coil 2 to the galvanometer. Now pass the current with the help of a battery. If current is passes through the first coil, the galvanometer shows the deflection in the second coil. So you are able to see, if we pass the current with the help of a battery in the first coil, there is a deflection will be found in the second coil in the galvanometer. So if we disconnect the current, the needle moves in the opposite direction and it comes to the rest. That indicates that no current will be flows. So this shows that current is induced due to change in magnetic field. So that means here we are passing the current, and as copper wires are connected here, there is a change of magnetic field will be takes place. As a result of this, the current will be induces in second coil also. So this is an activity to shows the change in magnetic field produces induced current. So after knowing this, one more important concept, it is the Fleming's right hand rule. By knowing all the previous concepts, so it is also very simple concept. So in previous class itself we have studied the Fleming's left hand rule. So now this is called as Fleming's right hand rule, and this is also very important concept. So first, what is the use of this Fleming's right hand rule? So it is used to find out the direction of motion of a force, magnetic field and induced current. So that means in any given conductor, if the current is flowing, if we want to check the direction of magnetic field, induced current or motion of force, we can use this Fleming's right hand rule. So it states that, what it states, so it's very important. It states that, so this is called as right hand, hence stretch your right hand such that the thumb, the forefinger and the middle finger of the right hand, so stretch the right hand such that this is the thumb and this is the forefinger and this is the middle finger. They have arranged in such a manner that they are always mutually perpendicular to each other. That means the angle between these two is 90 degree and the angle between these two is also equal to 90 degree. So after arranging, it indicates, so the thumb always points in the direction of motion of the conductor, and the forefinger indicates the direction of magnetic field, and the middle finger always shows the direction of induced current. So that means magnetic force, in the sense we are keeping the bar magnet inside the coil, that is called as motion of the conductor or force, and magnetic field will be changes in this direction. So hence the forefinger indicates the direction of magnetic field and the current induced, so induced current, this is indicated by the middle finger as shown in this diagram. So this is very important, try to keep in mind. So once again I would like to repeat this Fleming's right hand rule. So it states that stretch your right hand such that the thumb, the forefinger and the middle finger of the right hand is held always perpendicular to the each other, such that the thumb indicates the direction of motion of the conductor and the forefinger indicates the direction of magnetic field, then the middle finger indicates the direction of induced current. So whatever the concepts I taught today, these concepts are very important for your upcoming exams and even for your higher classes also. So try to learn all these concepts, observe the video, and after observation if you got any doubts, just make me a call or send your doubts through the WhatsApp. I'll try to clarify your doubts, and whatever the questions I am sending through the WhatsApp, try to answer and send me back. So take care your health. Health is very precious. Thank you. Have a nice day.